Hello, everyone. This is our final solar panel project. I'm Kavika Kirov.
I'm Austin Lau.
And I'm Luke Herman.
And we're going to show you what we did.
We were tasked with charging a battery using a provided solar panel, while also being able to read power voltage from the solar panel and the battery, and the current to and from the battery. We also had the additional purpose of displaying the state of the battery on the LCD.
So part of our process was figuring out what went where, plotting which pins went where, what connected with what, and it does help that we did already do labs on these. So we already kind of knew what went where, and from there, it was more troubleshooting, as well as figuring out the battery cable connecting to the VIN minus and VIN positive.
All right, we're going to show you the little demonstration we did outside. So here we are. This is our first page. This is our second page. And you can see it's charging right now, fully lit, and it's showing our current. Going to the next page, it's charging, covering it. It's not charging. And a little cool thing we have is if you go to the last page, you can turn the LCD off with the potentiometer. A little overview of the schematics that we did. You can see we have all the parts such as the INA 219, the solar LiPo charger, the solar panel, LCD, and we have our resistors to the right, 323,000 and 816,000. That's our voltage divider for the solar panel reading. We have our imports of the board time and other imports that we imported. Here we have kind of the pins of the Arduino. So really quickly, we have our backlight pin, our charge status, our P-good status, our solar pin where our solar panel voltage comes into, which is regulated by the divider. And at our A4, we have the button and then board A5 is the output to, or I mean, sorry, the input to the potentiometer. Here are the current sense code right here. We'll use this later in our while true. For right here, this is our LCD inputs. And these are how we created our characters. So in each one of these, really quickly, this counts as, this is like one um, row of the LCD, and you can adjust each pixel by changing it to a 0 or 1. And we made some custom characters for the sun, current battery, and we'll talk later about this battery right here. This is basically battery 0 is 0% battery, meaning the character will kind of look like there's no juice in it. And all the way to 100, it'll be pretty much full. This is our characters or variables. And for reading the battery percentage, you can't really just go from 0 volts to 4.2 because the battery stops working at 3 volts. So what we did is we made variables for at the battery at 3 volts, it's pretty much dead. Anything below that, it's not really going to work and it's dangerous for the battery. And full is about 4.2. Now, we made a range with this and we calculated the percentage. It's not the most accurate percentage, but it works. Okay, now for measuring current, we took the current from the current sense, the power we took from the current sense, and the bus voltage of the battery we took from the current sense. Uh, for our button state, we equaled it to our button value. So this is our current button state. And for our last button state, we set it as true. And when the button is not being pressed, it is at true. So basically what this code is saying is if one of them is, if they're not the same, then complete the code. And we've made it so it would go to the next page when you press the button. And we have 4 pages. And this is saying if we get to the 4th page, go back to page 1, or in our code, 0. Now for status, we made a variable just saying the charging, and If the P good value is set, then if it's not set, then it will be as not charging. Quickly, this is our code for letting the code know the percentage that we were talking about the variable. This allows the code to see if the percent is less than 0.24, then we set it as the character as 2, which is kind of like the empty battery cell. And if we go all the way down here, if it is a little higher, 0.96, then it's pretty much the full character.
So in all, the summary of our project, we pretty much just successfully met the requirements of the project, and we learned a lot about the time management and the time it took to take time out of our day to work on the project, along with a lot of time we were given during labs. We figured out the code and how to design our circuits to make them look not as ugly, as well as organizing our circuits to, fix like the design aspect of it. We ran into a lot of difficulties, including wiring certain things, maybe in the wrong spot, or maybe something just didn't work the way we thought it did. And through that, it required a lot of troubleshooting to fix those problems and make sure everything was ironed out.